The location of an object, position. In science, position refers to where an object is located in space at a given time. Imagine trying to find your friend in a crowded shopping mall. Just like you need specific information about where your friend is situated among the many people and stores, determining the location of an object requires knowing its position relative to a reference point or a coordinate system. In both cases, whether you're navigating the mall or pinpointing an object's location, you rely on coordinates or landmarks to identify exactly where something is amidst other objects. A change in an object's position. Motion. Motion is when something moves from one place to another. Imagine trying to find your keys in the morning after they've been misplaced. This scenario is much like an object changing its position, as both involve a shift from an original location to a new one. In this analogy, your keys represent the object. Their initial spot is the starting position, and wherever you eventually find them is the new position, illustrating the concept of an object's change in position. The distance an object travels per unit of time. Speed. Speed is how fast something is moving. Imagine you're trying to finish a jigsaw puzzle before dinner. Just like how the puzzle pieces need to fit together within the time you have, speed is about how much distance an object covers within a certain time frame. In this analogy, each puzzle piece represents a unit of distance, and the time before dinner is your unit of time. So completing the puzzle efficiently is akin to an object traveling quickly, as both require maximizing progress within a limited time. Speed and direction of a moving object. Velocity. Velocity is how fast an object is moving and in which direction. Imagine trying to find your way to a friend's new house in a busy city. Just like needing both the address, direction, and your walking pace, speed, to arrive on time, an object's velocity requires both how fast it's moving and where it's headed. Therefore, just as you can't successfully reach your destination without knowing both how to get there and how quickly you're moving, an object's velocity is defined by the combination of its speed and its direction. A change in velocity with respect to time. Acceleration. Acceleration is how quickly something speeds up, slows down, or changes direction. Imagine you're trying to get comfortable in bed, constantly shifting your position to find that perfect spot. This is similar to how acceleration works in physics. Just as you change your position to achieve comfort, an object's velocity changes over time to reach a different speed or direction. In this analogy, your movement in bed represents the change in velocity, while the time it takes to find that cozy position is akin to the time over which acceleration occurs. The push or pull exerted on an object. Force. In simple terms, force is what makes an object start moving, stop, or change direction. Imagine trying to move a heavy couch across the living room to rearrange your furniture. Just like you need to exert a push or pull to get the couch moving, forces in physics involve the same principle of exerting a push or pull on an object. When you push on the couch, you're applying force to overcome friction and inertia, similar to how any force in nature acts to change an object's state of motion. The tendency of objects to resist any change in motion. Inertia. Inertia is an object's natural resistance to changes in its speed or direction. Imagine trying to get out of bed on a cold winter morning when you're wrapped snugly in a warm blanket. Just as your body resists leaving the comfort and warmth of the bed, objects naturally resist changes to their current state of motion or rest. This reluctance to move or stop moving is similar to the concept of inertia, where just like your body wants to stay in the cozy bed, an object at rest wants to stay at rest. And an object in motion wants to keep moving unless an external force acts on it. The attractive force between all objects that have mass. Gravity is a force that pulls objects toward each other, like how Earth pulls us toward its surface. Imagine trying to keep a messy room tidy, where every item seems to have a mysterious attraction to the floor. Just like how those objects seem irresistibly drawn to the ground, gravity is the force that pulls objects with mass towards each other, like the Earth pulling everything towards its center. In this analogy, the floor represents the Earth. The scattered items are the objects with mass, and their tendency to fall and stay put is akin to the gravitational pull that keeps us grounded. Measure of the force of gravity on an object. Weight. Weight is how much gravity pulls on an object. Imagine you're trying to carry a backpack filled with groceries up a flight of stairs. Just like how the backpack feels heavier depending on how many items you pack into it, the weight of an object is essentially how much the Earth's gravity is pulling it down. In both cases, the heaviness you feel is a direct result of an external force acting on the mass you're trying to lift. Whether it's the force of gravity on the groceries or the strain on your arms as you climb the stairs. The force that opposes motion between two surfaces that are touching. Friction is the resistance you feel when you slide one object over another. Imagine trying to walk across a floor covered in scattered marbles. Just as those marbles make it difficult for you to move forward smoothly, friction opposes the movement between two surfaces in contact. In this analogy, your feet are like one surface. The marbles represent the roughness of the other surface, and your struggle to move mirrors how friction resists the motion, highlighting the challenge of overcoming opposition to achieve movement. The use of force to move an object over a distance, its unit is the joule J. Work is when you apply force to something and it moves. Imagine trying to push a heavy shopping cart across a supermarket parking lot. This task is similar to the scientific concept of work, where you apply force to move an object over a distance. Just as you exert effort to push the cart, in physics, work is done when a force moves an object. The energy used is measured in joules, akin to the energy you use to push the cart forward. A device that changes a force with one movement, like a lever, inclined plane, wedge, screw, wheel and axle, or pulley. Simple machine. A simple machine is a tool that makes it easier to move or lift objects by requiring less force. Imagine trying to move a heavy couch across the living room floor by yourself. Just as it's difficult to exert enough force to shift the couch without help, a simple machine helps us redirect or multiply our effort to make tasks easier. In this way, a lever or pulley acts like a helping hand, allowing you to lift or move heavy objects with less effort, much like how sliding furniture on a dolly makes moving it more manageable. A simple machine that consists of a bar that pivots on a fixed point. Lever. A lever helps lift or move heavy objects by using a pivot point to increase force. Imagine trying to open a stubborn jar lid that just won't budge. Much like how you might use a spoon to pry open the lid by leveraging the edge of the jar, a lever operates by using a bar that pivots on a fixed point to move an object. In this analogy, the spoon acts as the lever, the edge of the jar serves as the pivot point, and your hand applies force to achieve the goal of opening the jar, showing how a lever amplifies effort to accomplish a task with less force. Fixed point on which a lever pivots. Fulcrum. A fulcrum is the support or point that a lever balances on and uses to lift objects with less effort. Imagine you're trying to open a stubborn jar lid, but it just won't budge. Just like when you find the right spot to grip the lid and apply pressure, a fulcrum is the fixed point on which a lever pivots to make lifting or moving an object easier. In both scenarios, the jar grip or the fulcrum acts as the central point that allows you to apply force more efficiently, making a tough task manageable. A simple machine made of a wheel with a rope around it. Pulley. A pulley helps lift heavy objects by changing the direction of the force needed. Imagine trying to lift a heavy box onto a high shelf by yourself. Just like asking a friend to help you lift the box makes the task easier, a pulley uses a wheel and rope to distribute the weight, making it easier to lift heavy objects. In this analogy, the friend represents the wheel's role in the pulley, while the rope acts as your combined effort, working together to make lifting manageable. A simple machine made of a wheel with a rod joined at its center. They rotate together. Wheel and axle. A wheel and axle is a device that makes it easier to move or lift objects by reducing the force needed through rotation. Imagine trying to open a tightly sealed jar lid with just your fingers. In this situation, you might wrap a towel around the lid for a better grip, which makes it easier to turn the lid. The towel acts like the wheel, giving you more leverage, while your hand is like the axle, applying force to twist the lid open. Just as the wheel and axle work together to magnify your effort, the towel and your hand work together to increase your grip and force, making it easier to overcome the resistance of the jar lid. A simple machine with a flat, sloped surface. Inclined plane. It is a flat surface tilted at an angle used to help move objects upward with less effort. Imagine trying to push a heavy shopping cart up a steep curb. Just like how using a ramp makes it easier to push the cart up instead of lifting it directly, an inclined plane helps move heavy objects to a higher elevation with less effort. The curb is like the height you need to overcome. The ramp is the inclined plane, and pushing the cart up the ramp requires less force over a longer distance, just as using an inclined plane reduces the effort needed to lift an object. A simple machine made of an inclined plane wrapped around a cylinder. Screw. A screw is a tool that converts rotational force into linear motion, making it easier to hold things together or lift objects. Pull. Imagine trying to push a heavy shopping cart up a steep ramp into a store. Just like that challenging incline, a screw is essentially an inclined plane wrapped around a cylinder to make tasks easier. In this analogy, the steep ramp represents the inclined plane, while the cylindrical path of the screw is akin to wrapping that ramp around a pole, making it easier to drive into surfaces by spreading the effort over a longer distance, just as a gentler slope makes pushing the cart less strenuous. A simple machine made of one or two inclined planes. Wedge. A wedge is a tool used to split or lift objects apart by converting force applied to its wide end into force at its narrow end. Imagine trying to split a log of wood with an axe. This task is similar to how a wedge works as a simple machine. Just as the sharp edge of the axe, the wedge, is driven into the log to separate it into pieces, the wedge's inclined planes exert force on the material to divide it, making it easier to split. Here, the edge of the axe represents the wedge, while the force applied to the axe corresponds to how the inclined planes of the wedge help separate the wood with less effort. The force used on a simple machine. Effort force. Effort force is the push or pull applied to a machine to make it work. Imagine trying to open a tightly sealed jar of pickles. Just like you apply a certain amount of twisting force to loosen the lid, an effort force is the force you apply to a simple machine to make it work. In both cases, the effort you exert, whether it's the twisting motion on the jar or the applied force on a lever, is necessary to overcome resistance and achieve the desired outcome, such as opening the jar or lifting a weight. device that uses electrical energy to do work. Load. In science, a load is something that consumes electrical power, like a light bulb or a motor. Imagine trying to open a stubborn jar lid that just won't budge. In both cases, whether you're twisting a jar lid or using a device like a blender, you're applying energy to achieve a specific goal. Just as your hand uses physical energy to twist the lid and eventually pop it open, a device uses electrical energy to perform work, like blending ingredients. The jar is your task, your hand is the energy source, and the device, like a blender, is essentially doing the same job with electricity to accomplish work more efficiently.